Welcome aboard, where aviation concepts become simple. From instruments to aerodynamics, we make exam prep clear and cockpit learning faster. This is StudyKwik Aviation.
Welcome to StudyKwik. In this lesson, we are going to look at pressure heads and the pressure instruments they serve. To understand their function, we first need to define static, dynamic, and pitot pressures, and identify the flight instruments which use them. Static pressure is the pressure felt on an aircraft as a result of being in the Earth's atmosphere. It is present even when the aircraft is not moving, and is felt equally all over the aircraft. When the aircraft moves forward through the air, the leading surfaces experience an additional pressure due to the impact of the airflow. This is called dynamic pressure. The full dynamic pressure is experienced when the airflow is brought to rest against the moving aircraft. In simple words, dynamic pressure is the force the air exerts when stopped against a moving body. The combination of static pressure and dynamic pressure is known as pitot pressure or total pressure. The word pitot comes from the French physicist who devised a method of measuring this total pressure. So, dynamic pressure equals pitot pressure minus static pressure. Instruments using pressures, static pressure only, the altimeter and the vertical speed indicator, VSI, static plus pitot pressure, the airspeed indicator, ASI, and the Mach meter. Pitot plus static also feed the air data computer, ADC. Note, pressure instruments may suffer from instrument error, usually caused by mechanical imperfections. These are covered in detail in lessons on each instrument. Pressure heads. Pressure heads are probes mounted outside the aircraft to sense pitot and static pressures. Pitot tube, a forward-facing, open-ended tube that must be positioned outside the boundary layer, the thin layer of air close to the aircraft surface, which could disturb airflow. It is fixed parallel to the aircraft's longitudinal axis to ensure accuracy. Inside, airflow may be stopped against a stagnation wall and then transmitted through pipelines to the instruments. Static head, a perforated tube with its forward end sealed. The perforations along its length allow only static pressure to enter the system. It, too, is aligned with the longitudinal axis to minimize airflow disturbances. Now let's look at pitot-static heads. In many aircraft, the pitot and static heads are combined into a single probe called a pitot-static head. In this setup, the static tube surrounds the pitot tube. Both systems stay separate. Each one has its own pressure line feeding its own instruments. To work correctly, these probes have some special features. The first is a heating element. This prevents ice from blocking airflow. The heating can slightly change air density, but the system is carefully calibrated to correct that. Next, we have drain holes. They allow water or moisture to escape from the system. Some air pressure is lost through the drains, but again, this is accounted for during design. So why do these systems matter so much? Because any error in sensing pressure can mislead the pilot. If the pitot tube gets blocked, the airspeed indicator will show false speeds. For example, if the pitot tube is frozen, but the static system still works, the ASI can start behaving like an altimeter. If the static port is blocked, then the altimeter and VSI freeze. The ASI also gives wrong readings. That is why most aircraft are fitted with more than one pitot-static system for safety and redundancy. History has shown accidents caused by blocked pitot tubes. In some cases, pitot heaters were off or not effective. This gave dangerously wrong airspeed readings. That's why pre-flight checks and maintenance inspections of pitot-static systems are so important. Let's summarize. Static pressure equals ambient air pressure. Dynamic pressure equals force of moving air when stopped. Pitot pressure equals static plus dynamic, also called total pressure. The instruments that use static pressure, altimeter and VSI. The instruments that use pitot plus static, airspeed indicator and Mach meter. The air data computer also needs both pressures to work properly. Pitot head equals measures pitot pressure. Static head equals measures static pressure. Pitot-static head equals combines both in one probe. A heating element prevents ice. Drain holes let out water. Both are calibrated to keep readings accurate. Next time you see an aircraft on the ground, look near the nose. Those little probes sticking out are the pitot-static heads. They quietly ensure safe and accurate flying. Like, comment, share, and subscribe.